In this problem, we want to simplify the square root of the cube root of x times the fourth root of x. When we're dealing with these problems that involve a radical, remember a radical is anything that is like a square root or a cube root or fourth root and so on, we first need to convert these to rational exponents. So a rational exponent just means a fractional exponent. So we're going to start with this first part, this square root of the cube root of x. And whenever we deal with a problem like this, just like order of operations or PEMDAS, we want to start with the innermost part of the problem and then work our way to the outside. So we're going to copy down the square root with its parentheses again. But inside of it, we want to simplify this or change it to a rational exponent. So the cube root of x is the same thing as x to the 1/3 power. Whenever you're dealing with a radical, changing it to a rational exponent, you take the radical index or the number, the small number on top of your radical sign, and you put that in the denominator of your exponent. So we have x to the 1/3 in this case. So now this has become the square root of x to the 1/3 times the fourth root of x. And now we're going to do this again. The square root in this case means that there's technically a 2 here. We don't write it, that's not the correct way to write a square root, but that's what a square root means. There is a 2 for the radical index. So this is going to become x to the 1/3 all to the, and now we're changing this square root to a rational exponent, so that's going to become a 1/2 exponent times the fourth root of x is going to be x to the fourth root is 1/4 power. And now we can keep going with simplifying this. So the next step is to notice we have x to the 1/3 all to the 1/2. Whenever you're raising an exponent to another exponent, you have to multiply them together. So we get the quantity of x to the 1/3 times 1/2. We'll do that off to the side. Whenever you're multiplying two fractions together, you just multiply straight across. So 1 times 1 gives us 1, over 3 times 2 gives us 6. So we get x to the 1/6 power, and that's being multiplied to x to the 1/4 power. And now we are multiplying two common bases. So they're both a base of x, which means we need to combine the exponents by adding them together. If this were an x and this were a y, there wouldn't be anything else that we could do to combine them. But because they're both x, we can apply one of our exponential properties that says just add the exponents and keep the base. So we get x to the 1/6 plus 1/4. And now again, we need to simplify those fractions, which we'll do off to the side. 1/6 plus 1/4. In order to add two fractions with different denominators, we have to find a least common denominator. And the least common denominator is the smallest number that each of these numbers, the 6 and 4, can divide evenly. So if you think about it for a moment, the smallest number that 6 and 4 can both divide into would be 12. So we need to change this 6 to a 12, and to do that we have to multiply it by 2, and when we multiply it by 2 we have to multiply the top by 2. This way we don't change our fraction. We're going to do the same thing over here. This 1/4, we have to multiply it by 3 to make this 4 become a 12. But because we're multiplying the bottom of the fraction by 3, we're also going to multiply the top of the fraction by 3. And when we do this, we get 2 times 1 is 2, over 2 times 6 is 12, plus 1 times 3 is 3, over 4 times 3 is 12. And now we have a least common denominator. So we can add these fractions together. We're going to add the top two numbers, 2 plus 3, and put that all over one of the denominators, which is 12. Doesn't matter which one you pick since they're both the same number, which gives us 5/12. So this is the same thing as x to the 5/12. And from here, we're just going to change this back to radical form since the problem did not start with a rational exponent. It started with radicals. So remember, the denominator is your radical index, meaning that 12 is going to go out here, and we're going to get x to the numerator's exponent. So this 5 becomes our exponent. So the square root of the cube root of x times the 4th root of x is the same thing as the 12th root of x to the 5th power. And we circle our final answer.